Section 6.2 is on applying properties of rational exponents. The first thing we're going to go over are properties of both exponents and radicals. And you should already have the properties of exponents in your notes, but I'm just going to refresh your memory. So you don't need to write them down if you already have them from the previous section. But just a reminder, the product of powers property, if you multiply, you add exponents. We have a power of a power property where you have a power to a power, you multiply your exponents. When you have a power of a product, so you have this product and it's to a power, you can distribute that power to each number inside the parenthesis. We have the negative exponent property, which says if you have a negative exponent, to make it positive, put it on the bottom, or if it's on the bottom, put it on the top. We have the quotient of powers property, which says when you divide, you subtract exponents. And the power of a quotient property, which means if you have a quotient to a power, just like we did with the multiplication, you can distribute this 1/3 to the top and the bottom. So those are your properties of exponents. Now let's talk about our properties of radicals, which we have not gone over before. First we have the product property. That says if you have the root of something times another thing, so let's say if you had the fourth root of x times y, you can split that up and write the fourth root of x times the fourth root of y. Same thing with the quotient property. If you have a quotient underneath a root, you can split it up on top and bottom. So if you had the third root of 16 over 10, you can rewrite that as the third root of 16 over the third root of 10. So the product and quotient property means you can just split up your roots. Let's apply these properties. First, let's apply the rational exponents property. You already know when you multiply, you add exponents, only if you have the same base. So we do have the same base, so this becomes 5.5 times a fourth is 3/4. Here we need to take, we have a power to a power. So we're going to multiply these first. So we'll have 8.5 times 2 is just 1. You don't need to write 1. Times 5.1/3 times 2 is 2/3. And now since you don't have the same base, you're done. That's simplified. So over here we do the same thing. You have a power to a power. So you have 4 times negative 1/4, which is just negative 1, times 3, and then again that's negative 1. To make those positive, put them in the denominator. And then since these both have an exponent of 1, you can just multiply, so it's 1/6. Okay, let's use properties of radicals. Okay, so properties of radicals. When you have two radicals times each other and it's the same root, like this is the cube root of 12 and the cube root of 18, you can simply multiply what's underneath the cube root. So 12 times 18 is 216. But now you need to simplify, so you need to find out what perfect cubes go into 216. By that I mean what times itself 3 times is going to give you something that goes into 16. So if you did, try 4. 4 times 4 times 4 gives us 64. So you could try and see if that goes into 216. But you're going to find that 6 times 6 times 6 gives us 216. So the cube root of 216 is 6. And that's your answer. So the same thing happens when you're dividing. If it's both the same root, like this is the fourth root of 80 and the fourth root of 5, you can actually divide them. And when you divide 80 divided by 5, you get the fourth root of 16. 80 divided by 5 is 16. Then actually take the fourth root. It's asking what times itself 4 times is going to give you 16. Well, if you take 2 to the 4th, that equals 16. So your answer is 2. So like radicals, are radicals that have the same index and the same radicand. So if I scroll up a little bit, the root itself, like this 4 and this 3, is the index, and this is the radicand. And that was a couple chapters ago, so this is just a reminder. So like radicals have the same index and the same radicand. So now we're going to add and subtract these roots and radicals. And I'm actually going to start over here with this example. The only time you can add or subtract is if you have like radicals. So that means that the index is the same and the radicand, or the number underneath, is the same. So here we have the 4th root of 10 plus 7 4th root of 10. So since they both have the same index, 4, and the same radicand, 10, we can add them. So think about it as like a variable. If you had an x plus 7x, there'd be a 1 in front of here, and this would be 8x. Kind of the same concept here. We have 1, there's a 1 out here, 1 4th root of 10, and we have 7 4th roots of 10. So if we add them, we have 8 4th roots of 10. And that's it, you're done. Same concept goes over here. Remember that 6 to the 1/5 is another way to write the 5th root of 6. So really you're doing the same thing, it's just written a little bit differently. So this 6 to the 1/5 is a term, and you have 7 of them plus 2 of them. So when you add them, you have 9 6 to the 1/5. It's important to keep your parentheses, because this is not 9 times 6 to the 1/5. You would have to do 6 to the 1/5 and then multiply times 9. We're not going to do that, we're just simplifying. So it's very important to keep your parentheses. So now we're going to throw in some variables and simplify. This is probably the most complicated part of this lesson. We're going to start over here. We have the cube root of 64y to the 6th, and we are to simplify this expression. Your first step is look at the 64, so always go to your constants first. And you're going to simplify this, so you're asking yourself, is there anything times itself 3 times that goes into 64? Well, I know that if I take 4 times itself 3 times, that gives me 64. So the cube root of 64 is 4. So I'm just going to take this in pieces. So that's done. The 64 is done. Now move to your y's. Now with variables, the y to the 6 means that there are 6 y's under here. This cube root asks how many groups of 3 exist underneath here. Well, there are 2 groups of 3. So the cube root of y to the 6th is y squared. And that's your answer. So let's move on to the next one. So the variables asked how many groups of 3, or here it asks how many groups of 4. But with the constants, you're asking what number times itself 3 times will give you 64. A little bit different thinking. So our first step here is we're going to use our quotient rule that says we can break this up and write the 4th root of m to the 4th over the 4th root of n to the 8th. And then from there, remember we're working with variables, so m to the 4th means that there are 4 m's underneath here. And the 4th root asks how many groups of 4 are there? Well, there's just 1. So your top is going to be m over, here there's 8 n's, so how many groups of 4 are there? There are 2. So this would be your answer. Think about if you had the square root of m squared. That would just cancel and you just get an m. That's because there's a little index of 2 here. So it's asking how many groups of 2 are there? Well, there's only 1, so your answer is m. Same thing when you have the 4th root and something to the 4th. They kind of quote-unquote cancel out, and you're just left with m. So this last one, same concept written in a different way. If you remember that 1/3 actually means a cube root. So you're doing the same thing except we're writing it a little bit differently. So you're going to take every single term to the 1/3 power. So 27 to the 1/3 power. Then when we have a power to a power, you multiply. So 3 times 1/3 is just 1. So we just have p. and 12 times 1/3 is going to give me a 4. Now this is where the simplifying gets tricky, because before you just had whole numbers here, now we have fractions. Remember that the 1/3 means the cube root of 27. Cube root of 27 is asking what times itself 3 times give you 27. Well, that would be 3. So your answer is 3p q to the 4th. So just take these all in pieces, one step at a time. So I have 2 more types of examples. This first one we've kind of already done, but I'm going to hit it again. It's writing variable expressions in simplest form. So here we're looking at the 5th root of 5a to the 5th times b. Look at your constant first. Is there anything times itself 5 times that gives us 5? Right away you might think yes, but there's not. Because if you do 1 times 1 times 1 times 1, that's just 1. And then if you go to 2, we're already like way over 5. So there's not something. So this 5 cannot simplify. So that's going to stay the 5th root of 5. That can't simplify. So move on to the a to the 5th. Remember that this 5 is asking how many groups of 5 are there in a to the 5th. Well, a to the 5th means that there's 5 a's. So there's only one group of 5. So this is just going to be a. Now this can simplify, so this is going outside of the root, and it becomes an a. If you go to the b, it's asking how many groups of 5 are in just a b. Well, there are no groups of 5 in this b. There's only one b. So that's going to stay under the root. So if it cannot simplify, it stays under your root. If it can, it goes on the outside. Then when you're done, just rewrite this in the front, so it's not like sitting out back all weird. So you have a times the 5th root of 5b. Let's try it again over here. Again, we're dealing with the 5th root. Look at your constant first, this 4. Is there anything times itself 5 times that's going to give you 4? No, not at all. So that's not simplifying, it stays under the root. Then go to your a. How many groups of 5 are in 8? Well, there's one group of 5, so an a out here, but you have leftover. If it's 8, you take out 5, you're left with 3. So that means 3 of them are stuck under the root. That can't simplify. And I'm going to move this a over a little bit. Okay, then go to the b's. How many groups of 5 are in 14? Well, there's 2. And then you have a leftover of 4 that can't simplify, so that's going under the root. And then the c to the 5th, how many groups of 5? Well, there's 1. So that c goes out here, and there's none left over. So then your answer, take the stuff that's simplified, write it out front. So I'll have a b squared c times the 5th root of 4a to the 3rd b to the 4th. So it's simple if you take it in pieces. The last thing I have for you, pretty simple, it's just adding and subtracting expressions with variables. And they have to have the same variable, just like you can't add 5x and 6y, obviously. So you can only add things that have the same root. We went over this with just numbers. They have to have the same radicand. So if you have 5 square roots of y and 6 square roots of y, that is 11 square roots of y. And that's it. Now, even if it looks more complicated, look at your variable. So cut off the coefficient. So look here, this is my variable, cut off the coefficient, this is my variable. See if they're the same. Here I have x, y squared, z. Here I have the same. They are the same, so I can add them. So do -2 plus a 6. So it becomes 4x, y squared, z. And that's your answer. So I have 3 examples here that I want you to try out and simplify the best you can.